So it's session 2016, number one, radioactivity of cobalt. The cobalt isotope is radioactive. أعطينا radioactive constant قد إيه in second minus 1. معنى الماس M0 is equal 1 gram. This is as intensity 0. Okay, ومعنى الماس is كلهم in atomic mass unit. We have also these givens. So calculate in years the period of, or this means the half-life of the cobalt. So we know that the half-life or the period is equal to ln2 over lambda, which means equals ln2 over 4.146 times 10 to the power negative 9. بس ما ننتبه إنه هيدا الجواب هلأ حيعطينا t in which unit. This answer here will be in second. But ليه؟ لأنه this is a period. But أنا ما بدي in second. The question is in year. So I should divide all this number by أول شي بدي أحول لشو لأوصل لyear. So لازم أقسم first by the number of hours, then by the number of days, then 1 year قد إيه بتساوي. So لكن this means I should divide by أول شي كم ثانية عنا. So divide by 3600 ثانية. Okay, and then كمان divide another time, so it have to be multiplied by قد كمان بدي أحول second. This is for 24 hours. And how many days do we have in the year? So أعطينا 365 days. So هيدا الرقم كله رح أقسمه على هودي. So this means I can just directly write like this وفي أحطها بهيدي الطريقة. Okay, so it's all over. أو فينا بكل بساطة شو نعمل؟ نطلع الأنسر here in second and then we divide by all this. So we'll get as answer 5.3 years. Now, part 2, determine at t equal to 0 the number of the nuclei presented in 1 gram. لنطلع النمبر نحن we have given the mass. So لازم يكون في عندي relation بيناتهم. The relation between these two is m over big M equal n over Avogadro's number. بما أنه we have n0, so this means it's m0. So this means n, the initial number of nuclei of cobalt equal to m0 over big M times Na. So it's 1 over, now the molar mass of the cobalt is 60. So here it's 60 times Na, it's Avogadro's number, it's also given 6.02 times 10 to the power 23. And then we get as answer, this will be N0, which is equals to approximately 1.00. So approximately 1 times 10 to the power 22 nuclei of كوبالت. يعني أساسا كان عندي بالسامبل هالقد عدد كوبالت. مع الوقت أكيد هيدا النمبر في عندي part حيعمل disintegration, so هيدا النمبر رح يقل. Now the question is, now in this part the question is define, I think here part 2, so في عندي بعد part 2b, okay, part 2b and let me see, yes, part 2b here, define the activity A of the radioactive sample. So in order to define the activity is the number of disintegration per unit of time. As unit, it's in BQ. Part C, determine the activity of the sample, but at the instant t equal 15.9 years. Now, in order to find the activity, so A equal, نحن كان طالب منا, can we have what we have the number before, okay? So لنطلع activity, let's see, do we have the period, do we have so we have the period. So هون لنطلع النمبر في عنا طريقتين. فينا يا نشتغل n equal n0 over 2 to the power n, or فينا نشتغل n equal n0e minus lambda t. So the question is find من خلالهم نحن we have to find who the activity. and we know that so نكنا طلعنا ال n by this way or this way both are correct, and we know that A equal lambda times n, so we can find the activity is equals to how much. So لكن في عنا أول step we have to find the number, and the second step we have to find the activity. طب كيف بنطلع now number remaining? N equal n0 over 2 to the power n. طيب we have n0, we still have to find what small n, يعني how many period خلال 15.9 years, how many period مرة. So we know that n is equal to small t over the period. It's 15.9 over the period. طلعت معنا ال period 5.3. لازم يكونوا same units. So this is in years and this is in years, then it's correct. So we get as answer هيطلع معنا it's approximately 3. So هيطلع عنا equals to 3. Then بعد ما نطلع ال n, we can find it's n0 over 2 to the power 3. وال n0 أساسا كنا نحن طلعناها طلعت 1 times 10 to the power 22 over 2 to the power 3. And then this will be هيك بنكون طلعنا ال n remaining. طيب which is approximately يعني equal 1.25 1 nuclei. بس السؤال مش هو number remaining، السؤال هو activity. so بدي ارجع اخد هيدي and put it here. Now we have to pay attention ان activity هي بالبكرال so it's SI unit. So لما بدي ارجع اخد اللامدا I have to take it in second minus 1، يعني بدي اخد اللي هو عطيني اياها given this one. So 4.146 okay times 10 to the power negative 9. Second minus 1 ال n remaining كنا طلعناها إياها it's here 21, and then we can get the activity which is approximately بيطلع عنا الجواب 5.2 times 10 to the power 12 BQ. So لكن على طول you have to pay attention. ما في طلع ال activity which is in SI unit BQ if I don't have lambda, if I didn't take lambda in SI unit which is second minus 1. Even لو اشتغلنا الطريقة التانية which is n equal n0 e minus lambda t لنطلع النمبر كمان is correct. So one of these two. Now, part 3, the disintegration of the cobalt gives rise of the nickel isotope Ni according to the following reaction. So calculate specifying the laws used, A and Z. So part A, according to law of conservation of mass number A, we have, just 1 minute. We have 60 is equal to 60 plus A, which means A is equals to 60. We have conservation كمان of Z, charge number. So we have 27 is equals to 28 plus Z, which means that Z equals to negative 1. Sorry, here A is equal to 0. I didn't pay attention. 60 minus 60. So here is A equals to 0. Okay. Now name the emitted particles. Part B. So بما انه طلع معنا A equal to 0 and Z equal to negative 1, this means this particle is the beta minus, which is E negative 1, 0. But we have always with the electron, we have the anti-neutrino 0, 0. So like in order to name, we have beta minus, which is the electron, and we have the anti-neutrino. Okay, now calculate in mega electron volt the energy liberated by this disintegration. In order to find the energy liberated, we know that E liberated equals, so it's the disintegration of 1 cobalt, okay? So أنا عم بشتغل بعد B1 مش sample here. So it's equal delta M times C square, which means mass before minus mass after, all multiplied by C square. So implies E liberated equal. طب M before مين عندي؟ عندي الماس للكوبالت minus M after عندي ماس للنيكل and plus شو عندي كمان after ماس للإلكترون all multiplied by C square. All of these are given. So إذا بجي بطلع على التيبل معنا الماس للCO, معنا الماس للنيكل, معنا الماس للإلكترون which we already found, and all is in U. So رح نحطهم هون. If we put the number here, so it will be 59.9190 minus 59.9154 plus the mass of the electron اللي هي الX عطينا إياها. Okay, and all this هيدي كلها multiplied by C square. Now all this part is in U. So الجواب حيطلع عندي 3.05 times 10 to the negative 3. But this is in what? In U. أنا بدي إياه in mega electron volt. So إذا بدي إياه in mega electron volt, I'll write here times 931.5. It's mega electron volt per C square, and I have here the C square مننساها times C square. So حولت من U ل mega electron volt per C square. We simplify, and then we get the answer in mega electron volt, 2.84 mega electron volt. This will be the energy liberated by the transformation of only one cobalt. Part D, determine now the energy liberated. كمان بدي energy liberated هلا. But the disintegration of what? Of 1 gram. طب ال 1 gram في بقلبه بس 1 كوبالت؟ أكيد لا. كنا طلعنا العدد. كنا عرفنا إنه ب 1 gram, okay, in 1 gram, I have all this number of cobalt. طيب إذا all this number of cobalt, طب ما energy liberated by only 1 cobalt is this much. طب by the whole number, so it's equal to how much? لكن هون, just here, I write it here, the solution of the part, this is part 3D. So 3D. بطلع الانرجي, يعني كأنه عم بقولك energy liberated total. When I say in 1 gram, طب هيدا ال 1 gram قد ايه كان في عدد؟ كان في عدد بقلبه 1 كان في عدد بقلبه 1 times 10 to the power 20 يعني times 10 to the power 22 nuclei. So I need the energy liberated of the whole number, which is equal to the energy liberated by only one CO, okay, times the number of this cobalt times N0. So هيطلع عنا ال energy liberated كانت 2.84 طلعت ميجا electron volt times the number 1 times 10 to the power 22. So we'll get 2.84 22 mega electron volt. And this will be the energy liberated by 1 gram, يعني by the whole sample. Part 4, knowing that the energy liberated by the fission of 1 gram of uranium is this much. يعني عم بقلنا كل 1 gram of uranium, okay, حيعطينا قد ايه energy liberated 5.127 times 10 to the power 23 mega electron volt. Okay, calculate the mass of uranium. So it's how much the mass whose fission will provide an energy equivalent. So add the energy to that liberated by the disintegration of 1 gram of cobalt. طيب ال 1 gram of cobalt هيدا قد ايه عطيني energy؟ عطيني energy this much. نعمل لها calculation. So it's 2.84 times 10 power 22 mega electron volt. طب قد ايه mass of uranium will give me this energy liberated? So we'll just do a crisscross. So the mass of uranium will be equal 2.84 times 1 over 5.127 times 10 to the power 23, which will be equal 0.055. هلا ننتبه, the unit is in gram, so 0.055 gram of uranium.